project is web-based document summarization, and I'm the only member of my group. The aim of this project is to develop a web service that allows users to upload TXT documents and returns them all term definition pairs within the document, storing those within a database. For example, the sentence PowerPoint is a presentation software created by Microsoft. The term is PowerPoint, and the definition would be the entire sentence. So the idea of this is to allow users to interact with an automatic flashcard generator that, given their notes, can create and store flashcards from those notes. For this project, I decided to stay within the realm of a RESTful API, allowing users to upload documents very similar to as in the license plate app. Looking at my UML diagram, there's four main parts to this application. The first is a front-end UI. This is a simple console-based menu option that allows the user to interact, logging in, selecting which documents they would like to upload, and viewing what they've already uploaded. This interacts with a Flask-based REST API. The REST API does all of the storing and queuing of documents to be processed. There's a document processing center, which consists of a RabbitMQ messaging queue along with worker nodes that subscribe to that queue and listen for any updates to it. And then there's the database, which is stored on a Redis database using key value stores. How such a system works is the user has to log on using the front-end UI. It then sends their login and password to the RESTful API, which combines those and hashes them, checking to see if the user already exists in the database. If they are not, they are asked if they would like to create a new user. This hash is then stored, and I make sure that every user's combination of a password and username hash is unique to maintain their state. This hash is then returned, and it's kind of used as a session variable to the front-end UI, allowing every request by the user to be made to pass along this hash. This is how I maintain uniqueness with users so that one user can't see another user's documents. So every key value store for a user, for example, all of their term definition pairs, every key starts with that user's hash so that one user cannot see another user's examples. All of these elements are hosted on GCP virtual machines. I chose to use virtual machines for their scalability as well as they're easier to replicate from an image using GCP's UI. The main kind of connector for all of this is that REST API, and I chose to use a Flask-based REST API in Python simply because we had worked with it before and I was very familiar with it. As well as I'm familiar with Python, and it lets me more easily handle things such as maintaining that steady state with the hash and sending documents and queuing everything up. I used a REST API interface, as mentioned before, message marshalling, so all of my API requests are serialized using pickle and JSON format. I also utilize a message queue with my worker nodes because the document processing takes a little bit. So by queuing up those documents, I free up that REST API for further requests, as well as those worker nodes subscribe to that queue and are constantly pulling from it, so I don't have to go and check which workers are free and which aren't. All of my data is stored in a key value store. I figured this was fitting for a term definition pairing, as well as everything stored on a virtual machine. Going to a demo of the project, this is the UI, text-based UI. So for example, let's say if we try and log in with someone who isn't a real user, like Sam Smith, we're told that this is an incorrect user. So instead we have to actually create a user. So we can click the new user option, and we'll do Sam as the user and Smith. Then we're given options to interact with the system. So if we press 1 and see our files, we have no files, so we can upload a file. For example, I'm going to upload testset.txt. And this uploads it, and it says that the upload was successful. So if we press 1, we can now see that test set is one of our available files. So if we do C key values, we're asked for a file. So we'll do testset.txt. And this returns all of those parsed out key value term definition pairs from the worker node. For example, rate. A rate is a measure of how some property varies with time. And these are unique per user, so I can't see any other users because of that hash system. And we can now log out. For testing and debugging, I found that keeping things simple worked the best, so implementing at most 2 interactions at a time, whether it be the Redis database and the API, the topic exchange and the worker node, or the UI and the API, only looking at an isolated set worked the best. I stored all my logs in a RabbitMQ topic exchange. This gave me a centralized kind of log database. I also seeded sample data for isolated testing, so seeding values into that Redis database, testing to make sure that the API works before even trying to send things to a worker node, seeding things in that MQ message exchange, and then seeing if the worker node properly extracts it from there. And doing this allowed me to test isolated components individually. As far as scaling goes, I do have a few bottlenecks. One of those is the worker nodes. Everything's stored in a virtual machine with the worker node, so to spin up another worker node and replicate it during times of high volume would take a little bit, as well as that worker node's running a Keras LSTM, which takes a little bit to process each document. My Redis database is stored on a single virtual machine, so I would need to, in times of high traffic, after more and more values come in, I would need to either vertical scale that by allocating more memory, or implement sharding, which is a more sustainable practice long term. Some interesting findings with this project. I learned that I had to be creative with the key value store to maintain uniqueness. As I wasn't using a traditional relational database, I still wanted to maintain that each user would only be able to see their data, so I had to set all of my keys having that initial hash of their credentials. I also found out that the document processing is fairly slow relative to everything else, and so I had to fix that with the scalable worker VMs in the RabbitMQ. I also learned that middleman is immensely beneficial. This means having that API handling all the requests for you, and then also delegating to other things such as the queue and the worker node, and not kind of vertical scaling with just having one supercomputer do everything. Delegating them to other nodes works the best, as well as consistency rapidly speeds up debugging. So for example, having that UI have consistent calls to the API, it ensures that I didn't mess up when typing any of my API calls, and it lets me quickly isolate the issue.